Hello everybody and welcome to a chat from the engineering desk. I hope you're all doing very well today. So today, once again, in a grocery store, doing a bit of shopping, and I thought let's try out the Pick and Pay brand of lamp. This is a much cheaper lamp. It is 100 Rand in South Africa, or what you would call probably about $7 or so US. This is a 5-watt lamp. Let's look at the packaging because you can't see what's written on the lamp. Doesn't have it on it. 5 watts, 41,000 K lumens. I didn't bother with the fact that it's cool white, because this lamp is not going to be put into use. I prefer warm white lamps. So firing it up, there we go. Very much light. Came with this. So let's set that aside over there. This comes apart quite easily. Yeah, it does. There's the LED panel. So straight away you can see there's only one set of LEDs for everything, and your resistors for what I presume is the current limiting. So let's quickly have a look at those resistor values. So here we have our microscope. Let's zoom it out. Change the view. Two ohms. Yep. Okay. What are the LEDs? Let's zoom in. You can't really see much inside it, but they look like single chip from what I can see here. So that's that. Set that aside and change the view back. Very good. Okay, this just pulls out. Looks like they've yeah, they just stuffed the wires through that little thing there, turned them and poked them through. So okay, the PC board is attached to the mains connections. That's why we can't get it out. A battery of undisclosed capacity resides in the base as per normal, and there's the board. So that was already adrift on account of having yanked the battery out. So let's vandalize the lamp a little further. By snipping off the red wire. The thing has reasonable ventilation. I could actually see the battery through these holes. But what further delights await us? So stripping that off. That's bright. Set the dome aside for a moment and bring in the multinational meter. Let's see if all those resistors are in parallel. Like so. Let's have a probe. Okay, Goomba. Let's try 200 ohms. Yeah, they're in parallel. Yeah, 0.8. Because you said that they're 2.2s. Yeah. Let's measure the voltage across them with the LEDs lit. So what I'm going to do, bring in a crocodile clamp and do this in a reasonably orderly fashion. Ah, still alive. So 0.2 volts. So that would be around 200 milliamps by the looks of things. 200 milliamps, 2.2 divided by 3. Let's bring in Pinkasio. Sorry about that. 2.2 divided by 3. 0.7. So 0.2 and divide 0.7 equals 285 milliamps. Fair enough. Turn the blinding light off. So that's going to burn for a reasonable amount of time, as advertised. Disconnect that. Let's see if we can ascertain the nature of this little IC over here. I see numbers on it, so there's your rectifier. I think that is going to be battery management over there. And there's your chip controlling the switch mode. There's nothing underneath the electrolytic. There's some caps on the output to that to the LEDs. These things are interesting. There's some clever stuff going on in the background. So, sorry about that. Let's go back to microscopic view. MT2513 sounds vaguely familiar. That's your bridge. Positive and negative on that there. What's that? Other way around as usual. Yeah. 435, that's the battery management. Don't think there's anything else of interest over here. There's your bridge. There's the chip that does the clever stuff. Those are diodes, 2 of them. Five tens. Those are probably the those are on the output to the LEDs, because there's your wires going to the LEDs over there. And there's a transistor. That's the main side of it. So those are probably the resistors for the that track the negative. The black wire goes straight to the rectifier, and the red wire goes to the rectifier. So if the rectifier decides to go short circuit, the interior of this is going to illuminate beautifully, because there's nothing stopping the current. There's no fusing. And then there's this circuitry which is involved with the low voltage side over there. So the mains comes in through there and goes to this chip, which is what echoes the light when you touch those two wires together. So that's that circuit. Yeah, interesting that the rectifier's got no protection on it. That's what you get with a a more sort of a budget sort of type lamp. Going on the other side. There's a resistor. There's another resistor. Transformer. How many pins has it got? It's got two sets of pins there and there. That's the output. So let's put you guys back to the other camera so you can see where I'm looking. There's your secondary of your transformer, and you can see it's connected to the LEDs. Yeah, there's one side of the transformer connected to the output of the rectifier, and yeah, that's a cap that lives at main voltage. That's a 400 volt capacitor, 4.7 microfarads. That's a chip controlling that. So you got a primary and you got your feedback winding. There's your secondary. And then this little circuit. It works, but you can see it is definitely a cheaper product and done quite differently from how the other products that I've reviewed were inside. There's definitely a difference. So you could hack this and increase those resistor values once again, and run these at lower output, and the battery of course will last longer, along with the LEDs lasting longer. And I think that's pretty much sum total of what we have to talk about here. This little lighty that we bought today. There we go. 5 watts. Yeah, I think we're done talking about that. As always, it came with one of these, a source of switches, as always, which is nice. Gathering them. That's it. So that's what happens when you buy one of the more budget lamps. It was interesting to see what's inside. They're all different. It's quite an adventure, this. So I guess where and when I find more of them, I'm gonna buy them, and we'll be having them here on the breadboard and dissecting them and seeing what makes them light up, as it were. So thank you for being here. Hope you enjoyed it, and I wish you a wonderful day further. I'll see you for more. And goodbye.